Friends, so last class we discussed about the chapter that is chemical effects of electric current. So in that the basic definitions we have discussed in the last term. So now in this class we are going to discuss about the detectors to be used for detecting the flow of electric current. That is how current is flowing in the circuit, that we are going to study here using the detectors. So how we will know the flow of current is there in that circuit. That we can study here by using the detector. So suppose when you enter inside the dark room, what you feel? You feel the darkness in the room. Then what you will do? Suddenly you go to the switchboard. Then you try to switch on the bulb, that is light. When you switch on the button, then what happens? Then the bulb will glow and the entire room will become bright. So how it will become bright? When you switch on the button of the bulb, then what happens? The current will flow, then the bulb will glow, then the entire room will become bright. So if suppose if you are sitting in some place in a home, then you will feel warm, then you go to switchboard, then switch on the fan, then what happens? The fan will be at initially at rest, means it is not rotating. Then afterwards when you switch on the fan button, then what happens? The fan goes on rotating, then you feel a little bit warmer, it is colder. So then why it is rotating? When you switch on the button of a fan, then the current will flow, then the current will glow and the fan will rotate. If you are watching TV, if you want to watch a television, then whatever we will do, we will switch on the button of the television, then the television will on, right? So these are some of the electrical appliances. By using those appliances, that we come to know about that there is a flow of electricity will be there, right? See here, the detectors to be used for detecting the flow of current, right? When current flowing through the circuit is too weak, so if suppose the current flowing through the circuit is too weak, then what happens? The bulb will not glow, right? Then the bulb will not glow, or else any appliances, any electrical appliances that will not run. So at that time we have to use the sensitive detectors, more sensitive detectors. So see here, when the current flowing through the circuit is too weak, it means too less, then the bulb will not glow. Then the bulb and the other electrical appliances that will not run. Then in such a case we have to use more sensitive detectors. It means when the least amount of current is flowing through the circuit, then we have to use to know that the current is flowing, the flow of current is there, then we have to use the more sensitive detectors. Those are what? LEDs and magnetic compass. LED means what? Light emitting diode, right? LEDs and magnetic compass are used. So first thing, LED means what? A light emitting diode, right? So it is an electrical device, right? It is an electrical device or electronic device. So it starts emitting light even when a very small amount of current is flowing through the circuit, right? It starts emitting light even when a very small amount of current is flowing, that is passed through the circuit. The least amount of current is passed through the circuit, then also the bulb, then also the LED will glow, right? It has two terminals, that is positive and negative terminal. So see here, this is the diagram of LED, right? So it has two terminals, right? That is, one is longer terminal, one is shorter terminal. The longer terminal we called as a positive terminal and the shorter terminal we called as a negative terminal. So the LED has the two terminals, that is positive terminal and negative terminal. So LED can get in different color. The LED bulb or LED light can get in different colors, right? If you want the red color, means you can get red color. Whatever color you want, you can get in market. The LEDs you can get in different colors, right? Next thing, behavior of solids toward the flow of current. So what is the behavior of solid toward the flow of current? So here some of the solids they are given: plastic, copper, eraser, that is rubber, mastic and pencil lead, that we call it as a graphite, right? These are here, some of them are conductors, some of them are insulators, some of them are non-conductors, right? So see what is the behavior of these solids when the flow of current is there. So see here, this is the circuit diagram, that is LED. that LED is connected to the battery, that is cell, and the LED is connected to the 2 points. So one terminal of the LED is connected to the cell, that is positive terminal, and the negative terminal is connected to the point B, and the negative terminal of the cell is connected to the point A. So this is an open circuit, it is not a closed circuit. It is open circuit, then it is open circuit, so here the LED will be off. When the circuit is closed, it means there is a connection between point A and B, then the current will flow, then the LED will glow. So now initially this is the open circuit, there is no connection between the point A and B. So here in between point A and B, we are going to place some of the solids. Here they have given these solids, we will place there. So first thing, they have given the plastic. So here we are placing between the point A and B, we are placing the plastic. So you know that plastic is an insulator, it will not conduct electricity. So it means there is no flow of electricity. So plastic is an insulator, there is no conduction of electricity. So there is no flow of electricity. Then what happens? The bulb remains, the LED remains off. It will not glow. Why? Because the plastic is an insulator. Then remove the plastic. So the second they have given copper. It means copper wire. So they remove the plastic and place copper. So copper wire. So what do you know that when you know about the copper, that the copper is a good conductor of heat and electricity. So it means it will flow the electricity, right? When we place the copper wire between the point A and B, then what happens? The circuit will become closed. It means the circuit will become closed. Then the current flows to the circuit and the bulb switch on. It means bulb start glowing when we place the copper wire. Then remove the copper wire, then place eraser, that is rubber, right? So then remove the copper wire, place here rubber. So what do you know about the rubber? The character, it is an insulator, it will not conduct the electricity. So it means there is no flow of electricity between the point A and B. When we place rubber between the points A and B, then the flow of current will not take place in the circuit, then the bulb remains, then the LED remains off, right? Then remove the rubber, place the mastic there. Between the point A and B, we are going to remove the rubber that we have placed initially now. Then we are going to place the mastic between the point A and B. That is, mastic is a wood. So wood, we know that it is an insulator, it is a bad conductor of heat. Then there is no connection between the point A and B. It means there is no flow of electricity between the point A and B. Then there is no flow in the circuit. Then the LED remains off. It will not start glowing, right? So next thing, remove the mastic, that is wood material. Then place the lead. We call it as a graphite. So graphite is a good conductor of electricity. So when we place the graphite between the point A and B, so graphite, we know that it is a good conductor of electricity. Then what happens? There is the flow of current between the point A and B, right? Then the flow of current will take place in the entire circuit. Then the LED starts glowing, right? Why? Because it starts glowing because the graphite is a good conductor of electricity. So these are some of the behaviors of the solid toward the flow of electricity, that is electric current. Detector based on the magnetic compass. So you know that magnetic compass, where we are going to use the magnetic compass to know the directions. There we are going to use the magnetic compass. So to detect the flow of electricity in the circuit, there also we are going to use the magnetic compass, right? So how? See here, this detector is called as a, so this type of detector is called as a magnetic effects of electric current. So the detectors where we are going to use the magnetic compass, that we called as a magnetic effect of electric current. So when what happens? See here the diagram carefully, right? A magnetic compass is placed in a matchbox tray. That is, it is wrapped with a copper wire or a wire, right? Those wires is connected to a cell and another end is connected to the 2 points, that is A and B. So place here conductors, and what happens? The current will flow through this circuit. Then when the current flowing through the circuit, then what happens? This magnetic compass or magnetic compass present in the matchbox, this magnetic needle will deflect. even though there is a very small amount of current is flowing through the circuit, then also this magnetic compass will deflect, right? So that's why the magnetic compass is also used as a detector to know the flow of electricity in the circuit. So see here, the detectors based on the magnetic compass can be made as follows. So here, with the help of these tips, we can make the magnetic compass to find the flow of electric current in the circuit. So first, place a small magnetic compass in an empty matchbox tray. I told you that in the matchbox tray we kept a magnetic compass. So here there will electron only. Place a small magnetic compass in an empty matchbox. Second point, wrap an electric wire, that is wrap the electric wire around the tray a number of times. So number of times they wrap the electric wire to the magnetic needle, that is magnetic compass placed in a magnetic box, that is a matchbox. Then the two free ends of the wire then can be used for connecting it to the other components of the electrical circuit. So these two, the free ends that can be connected to the other component of the electric field, right? That is conductors, insulator. Then you can connect here conductor insulator. Then you can see the flow of electricity, that it will detect the flow of electricity or else not, that we can study. So next, the flow of electricity through liquids and solutions, right? The flow of electricity through the liquids and solution, that we are going to see. So you know that some of the liquids and the solutions will conduct the electricity and some will not conduct the electricity, right? So where electricity is conducted in the liquid. So in pure liquids, the electricity conduction is more, right? It conducts the electricity. Second thing, the solution of electrolyte. Right? In my first video, I have told you that what is electrolyte, what is not an electrolyte. In the solution of electrolyte in water, so those solutions are such solution of acid, base, and sulfur. So there, the conduction of electricity will, that the flow of electricity will take place. Then the solution of non-electrolyte in water, that is the solution of sugar and glucose. There also the conduction of electricity will take. So in molten electrolytes, there also the flow of electricity will take place in that solution, right? So in this class we have learned about the detectors, how detectors of the electricity, the flow of electricity, that we have learned. Then the flow of electricity through the liquids and solutions, that also we have learned. So in next class we will study about the chemical effects of electricity, that is chemical effects of electric current, that we are going to discuss. I hope you understood all these concepts, whatever I taught in this class. Thank you.